Bismillahirrahmanirrahim. Dear student, Assalamu alaikum. It's me, Dr. Mansoor Khan, Assistant Professor, Department of Chemistry, Kohat University of Science and Technology. The course which is assigned to me is Electrochemical Methods with a course code CHEM452. Today I am going to deliver my 22nd lecture, which is based on caulometric methods and its type. So in our today's lecture, we will discuss the basic principle of caulometric method, its instrumentation, application and its types. This slide shows the outlines of this lecture. So in this lecture we will discuss about what is caulometry, its basic principle, instrumentation and its application in analytical chemistry. We will also discuss about its type, which include empiristotic method of caulometry, its basic principle, instrumentation and application. We will also discuss about the potentiostatic method of caulometry, in which we will discuss the basic principle, instrumentation and application of potentiostatic method of caulometry. Now the second part of our presentation is the basic principle of caulometric method. This is our main goal. In this whole chapter we will discuss caulometric methods, which is used for qualitative and quantitative method of analysis. So introduction. So a question arises that what is a caulometry? Caulometry is an electrochemical method based on quantitative oxidation or reduction of an analyte. In caulometry, we measure the amount of analyte by measuring amount of current and time required to complete reaction. An electrolytic method is equal to the external power added to the system. So from the amount of current which is added to the system is basically basis for the quantitative method of analysis. It means if the amount of analyte is greater, high amount of current, external current will be required, and if the low amount of current is required, it means that the concentration or the total amount of the analyte which is to be determined is low. Example, we will take also example for caulometric methods in order to understand fully the caulometric method. So the first one is caulometric titration of chloride. In caulometric methods of chloride, we take silver electrode to produce Ag. So what silver Ag will immersed in the solution of AgCl2, where Ag formation will take place. Measure amount of analyte by measuring the amount of current and time required to complete the reaction. Electrolytic method is equal to the external, the same like we have studied in the previous lecture. This is the overall reaction. The Ag first converted into Ag ion, and then the second is Ag combined with AgCl and leads to the formation of EPT. So the amount of Ag which is converted to the AgCl is basically used for the basis of concentration of the chloride. Another example is measuring of Ag in solution by second electrode. Only get complete circuit when Ag exists in the solution. Only occur after all the chlorine is consumed. So by measuring amount of current and time required to complete reaction can be determined by the amount of chloride. So it is the amount of Ag which is consumed will be the basis for the amount of chloride which is present in the analyte. So how the amount of Ag will be when the current is stopped, it means the whole Ag is the whole chloride is converted into AgCl. So from the amount of Ag, and from the amount of Ag we can convert the amount of current, from where we can determine the concentration of chloride which is present in the solution. Caulometric methods based on measurement of amount of electricity or charge in coulomb required to convert analyte to different oxidation state. This is another explanation of caulometric method. This is the equation which is used for, which is the base for the caulometric method. Q is equal to IT for constant current with time, where Q is the charge required, I is the current in ampere, and T is time. This slide shows the types of caulometric methods. Caulometric methods can be divided into amperostatic method and potentiostatic method. So in the next lectures we will discuss amperostatic method of caulometric methods and potentiostatic method of caulometric method. In this lecture further we will discuss basic principle, instrumentation and application of amperostatic caulometric method, and also we will discuss basic principle, instrumentation and application of potentiostatic caulometric methods. So what is amperostatic method? In amperostatic method, the basic is this is also called caulometric titration. Like we have earlier discussed the example of determination of chloride by using Ag using caulometric method. So that was the example of amperostatic method. So in amperostatic method, titration of analyte in solution by using caulometry at constant current to generate a known quantity of a titrant electrometrically. Potential is set by contents of cell. This is the example that we have discussed earlier, in which we determined the amount of chloride by using Ag as an electrode. To detect the end point, use electrode titrant. Applications. So the first application of caulometric titration is it can be used for acid-base titration. In acid-base titration, the neutralization reaction takes place. The titrant and the titrant are, one is acid and the other one is base, while the reaction between the titrant and the titrant is a neutralization one. So this is acid titration, in which H2 will take the production and will leads to the formation of OH, titrant generation, while this one is the base titration, in which the hydrogen ion production will take place. The second application, it can be used for complexometric titration of EDTA. EDTA stands for ethylene diamine triacetic acid. In this type of titration, a complex formation takes place between ligand EDTA and the central metal atom. Here HgNH3Y -2 is basically the ligand which react with NH4. So, and H4Y is Y-4 is basically the EDTA, which is used as a titrant, and it is in the 4 and it is hexadentate, and it gives 6 pair of electrons. It can also be used for redox titration. In redox titration, reduction oxidation takes place. Here cerium plus 3 undergo to cerium plus 4 by the release of an electron. So the process is oxidation, where cerium plus 3 is an oxidizing agent and is a reducing agent. On the other hand, the overall reaction is given where Ce plus 4 react with Fe plus 2. The Ce is 4 plus 4 is converted into Ce plus 3 and Fe plus 2 is converted into Fe plus 2. Ce plus 4 is a strong oxidizing agent. It leads and it's by itself reduced to Ce plus 3, while it oxidizes Fe plus 2 into Fe plus. Now the second type of caulometric method of analysis include potentiostatic method of caulometry. So what is the basic concept of potentiostatic method of caulometry? Is detection of analyte in a solution by using caulometry at fixed potential to quantitatively convert analyte to a given form. It means that the current will be measured at fixed potential, which is required to convert the analyte quantitatively into its desired form. In this method, current controlled by content of the cell. Instrumentation include electrochemical cell, which is electrolysis cell. This is also known as electrolytic cell, which we have discussed in our previous lecture in detail. A potentiostat which apply a required potential for the chemical reaction to occur. Integrator, analog or digital for determination of the charge which is consumed. This slide shows the instrumentation. So the first one is equivalent circuit. This is the equivalent circuit in which all the components arranged are given. The second one is electrochemical cell, which is known as electrolysis cell. The cell consists of cathode and anode and reference electrode, in which the oxidation and reaction takes place. This cell is known as electrolytic cell because electricity is converted into a chemical energy. Practical circuit of a potentiostat and electrochemical cell, which is electrolysis. This is the circuit of the practical circuit of the potentiostat and electrochemicals. Now, what are the advantages of potentiostatic method of caulometry? It is more specific than amperostatic caulometry. The amperostatic caulometry is, we can say, more specific as compared to amperostatic caulometry. In analytical chemistry, most of the technique are non-specific, or you can say interferences occur in most of the analytical technique. It avoids redox of species that may interfere with a constant current caulometry, so it can be easily specified. Can be used for over 55 elements without major interferences. While in disadvantages, does take longer than amperostatic titration. It means that this technique is slower, or we can say time consuming as compared to the amperostatic titrations. Current decrease with time. It means that their response is not constant. It means that the current decreases with time, and also conversion becomes slower as less analyte allowed to oxidize or reduce as the current decreases, so that's why the reduction and oxidation takes place slowly. Now, what are the advantages of potentiostatic method of caulometry? It is more specific than amperostatic caulometry. The amperostatic caulometry is, we can say, more specific as compared to amperostatic caulometry. In analytical chemistry, most of the techniques are non-specific, or you can say interferences occur in most of the analytical technique. It avoids redox of species that may interfere with the constant current caulometry, so it can be easily specified. Can be used for over 55 elements without major interferences. While in disadvantages, does take longer than amperostatic titration. It means that this technique is slower, or we can say time consuming as compared to the amperostatic titrations. Current decrease with time. It means that their response is not constant. It means that the current decreases with time, and also conversion becomes slower as less analyte allowed to oxidize or reduce as the current decreases, so that's why the reduction and oxidation takes place slowly. This slide shows the application of amperometric caulometric methods. The amperometric caulometric method is largely used in electroplating industries. In electroplating industry, it is applied the current potential. The metal of interest can be deposited on the surface of the electrode, and from the surface of the electrode, the metal of interest or the analyte which is deposited on the surface of electrode can easily be separated. So this purpose, for example, gold is plated over a silver in jewelry, and zinc is plated on steel for anti-corrosion, because zinc is non-corrosive as compared to steel. Here two terminology. One is vermil, referred to as silver items containing no less than 92.5% silver that has been plated with a gold or gold alloy that is no less than 10 carat to a thickness of not less than 2.5 micron. So this is one of the important application of potentiostatic caulometric method, which is used in electroplating industries. Thanks for your patience.